Hello, I'm Arnold Villaro, and welcome to this video on alkanoic acids. You can reach me at arnoldvillaro@gmail.com. Alkanoic acids, or carboxylic acids, feature the carboxyl group, COOH, as their functional group. They are classified as acids because they share similar properties with other acids. Some sources of alkanoic acids include lactic acids and methanoic acid, which is found in ants. Additional sources of alkanoic acids are found in lemons and oranges, and also in natural fats and oils. The general formula for alkanoic acids is CnH2n plus 1 COOH. Here, N represents the number of carbon atoms, 2N plus 1 is the number of hydrogen atoms, and COOH is the functional group. Let's determine the molecular formula of methanoic acid. Starting with the general formula CnH2n plus 1 COOH, when N equals 0, we find the formula is HCOOH. This slide further illustrates the derivation of HCOOH as the molecular formula for methanoic acid from the general formula, where N equals 0. This image shows the molecular structure of methanoic acid, which has one carbon atom double bonded to an oxygen atom and single bonded to a hydrogen and a hydroxyl group. The condensed formula of methanoic acid is simply HCOOH. Next, let's find the molecular formula of ethanoic acid. With N equal to 1, the general formula CnH2n plus 1 COOH yields CH3COOH. The molecular structure of ethanoic acid shows a methyl group bonded to the carboxyl functional group. The condensed formula for ethanoic acid is CH3COOH. Finally, for propanoic acid, setting N equal to 2 in the general formula, CnH2n plus 1 COOH, results in the molecular formula C2H5COOH. The molecular structure of propanoic acid is illustrated here, featuring a 2-carbon alkyl chain bonded to the carboxyl group. The condensed formula for propanoic acid is CH3CH2COOH. Now, let's look at butanoic acid. Using the general formula, where N equals 3, the molecular formula for butanoic acid is C3H7COOH. This diagram illustrates the molecular structure of butanoic acid, showing the arrangement of the 3 carbon atoms in the alkyl chain and the carboxyl group. The condensed formula for butanoic acid is CH3CH2CH2COOH. Moving on to pentanoic acid, with N equal to 4, the molecular formula derived from the general formula is C4H9COOH. Here we see the molecular structure of pentanoic acid, demonstrating the 4-carbon alkyl chain bonded to the carboxyl group. The condensed formula for pentanoic acid is CH3CH2CH2CH2COOH. The same principles apply to the other alkanoic acids, including hexanoic acid, heptanoic acid, octanoic acid, nonanoic acid, and decanoic acid. Alkanoic acids can be prepared through the oxidation of alkanols. This process involves oxidizing alkanols to alkanols, which then form alkanoic acids. Now let's explore the physical properties of carboxylic acids. They are generally soluble in water. Their melting and boiling points increase with a larger molecular size. Furthermore, the density and viscosity of alkanoic acids increase as their molecular size increases. Regarding chemical properties, alkanoic acids react with metals to produce salts and hydrogen gas. For example, ethanoic acid reacts with magnesium to form magnesium ethanoate and hydrogen. Alkanoic acids also react with potassium hydroxide to form potassium ethanoate and water. The chemical equation for the reaction of ethanoic acid with potassium hydroxide is shown here. Another chemical property is the reaction of alkanoic acids with sodium hydrogen carbonate, yielding sodium ethanoate, water, and carbon dioxide. This slide provides the full word equation and the corresponding chemical equation for the reaction between ethanoic acid and sodium hydrogen carbonate. Focusing on chemical properties, alkanoic acids also react with alkanols to form alkanoic acids and water. For example, ethanol reacts with ethanoic acid to yield ethyl ethanoate and water. This is the chemical equation for the reaction between ethanol and ethanoic acid, producing ethyl ethanoate and water. This image illustrates the molecular structure of the product, ethyl ethanoate. To test for alkanoic acids, phenolphthalein indicator is added to the unknown organic compound. If it's an alkanoic acid, the compound remains colorless. Additionally, alkanoic acids can be identified because they turn litmus paper red, as they are acids. Carboxylic acids have several uses. Ethanoic acid is used as a food preservative, a food flavoring ingredient, and as a solvent or antiseptic. Other uses include fatty acids in the manufacture of soaps and acetic acid, or ethanoic acid in the manufacture of rubber.